coming in hot. Coming in hot.
Hello everyone, we are moving on to our next tutorial. The question is asking us to draw the locus of a point on the periphery of a circle, which rules on a curved path. We have been asked to take the diameter of the ruling circle as 50 millimeters and the radius of the directing circle, that is the curved path, 25 millimeters. Alright, so before we start anything, we first have to find the angle for one complete revolution. And the formula is the diameter of the rolling circle, the radius of the rolling circle divided by the radius of the directing circle times 360. So in our case, the rolling circle has a diameter of 50, so a radius of 25. So 25 divided by 75 times 360, and that will give us 180. So we are going to begin by first drawing our 180 degrees angle. So I'll draw any line at all, and I'll use my protractor to mark out the 120 degree angle. Now let's note that you'll be dividing the rolling circle into 12 parts. So 120 divided by 12 is also 10 degrees. So you can mark out 10 degrees for each interval in addition. So we wouldn't have to go back to it again. So let's see. So now here's my 120. So I'll mark out the 10 divisions. I'm going to join them with a straight line. So this is the main 120 degrees angle, and the rest are all divisions. That's going to aid us to trace the point. Alright, so we have our divisions now. Now I'm given that the radius for the directing circle is 75 millimeters. So let's pick 75 millimeters with our compass. Alright, so that's 75. So you stand here and you draw an arc. Next, you draw the circle that's going to rule, and it has a diameter of 50, so a radius of 25. That's 25. So I'll stand here, inscribe an arc, stand here and draw. So that's the circle that's going to rule. Next, we stand here, open to the midpoint of that circle, and draw another arc. So that's the center line, sort of. Alright, so next I'm going to divide the rolling circle into 12 parts. So I'm going to pick the radius, then I'll inscribe arcs, then I'll just trace them. So I'll stand here, inscribe an arc here, then stand here, inscribe an arc, then stand here, inscribe an arc. So next, I'm going to draw axe from the point of intersection with the axe. So then I'll open to this one. Yes, it passes through. I'll draw the first one. Now open to this one. Now I'll draw the second one. And I'll move on. That's this one. Then finally, the last one. Alright, so here is our position of point P. The point P we want to trace. So let's start numbering. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then back to P. And here's our center point. Point C, center. Alright, so we have our centers to where we stand to. Here's our C1, 2, C3, C4, C5, C6, 7, and C12. Next, we stand at C and pick the radius P. So we stand at C and open to P, which is the same as the radius. Now we stand at C1 and inscribe an arc on arc 1. Move to C2. Oh, that radius has changed. Let me check. Alright, so we move to C2. Inscribe an arc on line 2. Sorry, arc 2 in this case. C3, arc 3, C4, arc 4, C5, arc 5. Okay, we didn't draw one for C6, so let's draw it right now. Open to 6. That's 6. Then you have the last arc for 6. So now let's pick the radius again. CP. So we reach point 6. So we stand at 6. Inscribe an arc. 7, 8, 9, 10, 11, then finally 12. So we have our point we will use to join the curve. Nice, yeah. I'm going to join it with a free hand. Yeah, and that's what we have. It doesn't matter the location of P. For instance, if P were to be placed here instead, you start numbering 1 from here, you pick CP, then just mark as normal. So the position of P doesn't really matter. All that matters is you getting the right steps and the right procedure to go about it. And this figure is called the epicycloid. Yeah, thanks.